So a little preview before I take it apart. Here's the instrument panel from the Skywell after it has been removed from the vehicle. Now, I'm going to be disassembling this and mapping the entire process, every tool that they have to pick up, every bolt that they have to pick up, every change between a Phillips, between a hex head, every component as it is being presented. I'm going to be accounting for all of that in my cost. And then I'm going to be costing the individual components. What would it cost to purchase that component, to manufacture that component? I'm going to be going through everything. Now there's a couple things here on the Skywell that I wanted to point out. The first, this top. Look at this corner. You see how it has this like chunk just floating out in space? Well, how do they manufacture that? This is not a vac form. This is not a thermoform. This is not a flat stock material that was cut and sewn. This is what's called a PVC slush mold or a rotocast. Basically, there is a giant tool. Normally it would be the size of 2 of these instrument panels. So you'd have kind of like one side and the other, and they'd slice it down the middle. They pour in a powder of PVC, heat the tool and spin it. As it is spinning, that powdered PVC sticks to the tool surface, melts together, and forms this skin. Now you can get a very nice replication of any of the grain and any of the features in a PVC slush mold. And you can also get these features like this. This could never be done in a vac form or a thermal form because this would stretch out like an overstretched balloon and tear. But with a PVC slush skin, you can have that type of feature. This skin is then placed into a mold. This plastic substrate is placed into that mold. It is closed up, and this foam is poured or injected between the two. It fills up all of the cavity, giving you a foam surface, but this foam also solves an issue. If you have die draw, or if you have B-side features, dog houses, that you do not want to have read through on the A-side surface, that foam, acting as an intermediary, hides all of those sins. The problem is, this is very expensive. This complete injection molding tool is expensive. This cast skin or rotocast skin tool is very expensive. And then the foaming tool is very, very expensive. So this is 3 expensive tools, 3 expensive processes, but it gives you an almost unlimited range of shapes. It can normally give you good quality as long as you don't mind the feel, which I don't like. And then it solves some sins in engineering. But for me, I would prefer a wrapped component just because now I only have a press tool and an injection molding tool. I've saved money on the tooling, and I can also save some money on the cycle time as long as I design the wrap properly and I can do an automatic wrap. Now looking at the rest of this plastic substrate. This is a surface. It is bonded to this plastic substrate by that foam, but this plastic substrate is hidden behind this A surface here. This A surface, this is one component all the way to here. This is a non-moving component. This does not open, this does not hinge, and it's almost the entire size of the instrument panel, but it's applied over top of this substrate. So I have 2 components. There is no relative movement. They do not have to be different materials. They're both plastic. By lean design principles, these should be the same part. So I could have a substrate that had a decorative A surface and still thermoform, or not thermoform, but rotocast my skin and apply it to a portion of it. Again, the glove box is a separate component. It has to be different, but this entire surround does not. So if I was giving them suggestions, that's one thing I would say is try to integrate this surface into your substrate to eliminate that large panel, the tool, the cycle time, and the installation. So this is kind of just like a little rant thing. I want to talk about this screen. Now, many people have iPads and other types of tablets that you purchase, and you look at the price of that component. Well, how much did I pay for my iPad? Well, this is basically same size as an iPad. It probably even has fewer features than an iPad. This should be the same price as my iPad. No, it is not. It's far more expensive. because this is unique for this vehicle. The attachment method, all of the different bracketry in the structure, it was designed for this vehicle. And because of that, you do not get an economy of scale. These screens can actually be quite expensive. Now they are coming down more, but these never get to be the same price as mass market electronics because of that economy of scale. So again, I've been picking on glove boxes recently. Now, if this was actually in vehicle, it would be sitting up another 90 degrees over. But in opening that up, there is tension in that cable. That's probably acting as a damping feature while it's opening, but I think it's funny at this angle, it's actually closing itself.
3 weeks later.
Welcome back to Munro Live and our continuing coverage of the teardown of the Skywell. Now, as you can see, the farther we go, there's actually less to see. We have ripped most of the interior, most of the structure out of this vehicle. Few major components left to go. I'm hoping by the end of today or tomorrow, I will have all of the body harness wiring ripped out. But we've already done a short video on the instrument panel as removed from the vehicle. Let's look at the individual components as they've been disassembled. Here are the major components of the Skywell instrument panel. Now, we talked about this a little bit. This is the main top pad, carrier panel, IP substrate, whatever you want to call it. Here's something that's a little interesting to me. Most of the time, these components, if they're going to have a cast skin like this in place, they will make these out of glass-filled polypropylene. And I've always had debates or fights with some of the people saying, well, we can't let any of this be A-surface because this has to be glass-filled. So we have to have additional components put on top. Well, I like looking here, none of this is glass-filled. They could have integrated some of the A-surface into this injection molding. Now, it would be a little more difficult since they have to do post-processing. So let me remind you of the process. They injection mold this substrate. This skin is a cast skin or a PVC slush mold skin. They have a giant tool that has the shape of the instrument panel in the tool. They pour in a powdered PVC material. That tool spins and heats up, and as it spins and heats up, that powdered material melts into a sheet across the surface. Then they rip that material out of that tool. They put the injection molding substrate into another tool. They put the skin into that tool, bring them together, and then they injection a foam between the two. You can see that right here. This point is the point where they actually had to seal off to nozzle, and then they would inject the foam. That foam would spread in that gap between this plastic substrate and that skin on the A surface. Now, how does that really help them? Well, it solves some engineering problems. One, die draw. If I'm injection molding this part, I have a die draw basically in this direction, but my skin can be in a different die draw. See right here, I have an undercut. I'm able to have my skin and my substrate be in different die draws. That foam fills in. That enables me to have more shapes. So I can solve a die draw issue by having that foam in place. Very tight corners. This is a corner that you could not do if this was a cut and sew material or if this was a material that you were trying to stretch. You just could not do that corner. But with the PVC slush, you can make almost any shape that you want. But there's still more processing on this. Now, one very expensive tool, two very expensive tool, then the foam tool. Do I have a finished part? No, I don't. Look at this edge. The foam bleeds out from around the perimeter of the material. Now the slush skin extended a little bit farther. After the foam tool came through, they literally came in and they cut this material. Looking at the jaggedness of this cut, this was probably done by hand. Now think about this. This is a surface. This is something the customer is going to see. Do I want an operator with a razor knife dragging a knife so close to my finished surface? What if I accidentally nick that? Now I've scrapped the entire part. Okay, so that's a hand operation for trimming, but what about this one? For this air vent to have this clean of a line going through the PVC skin, through the foam, and honestly the plastic completely filled in here, they needed to cut out for this defrost air vent. This is all milled. So a milling machine has to come in, do this process. They milled in 2 other locations, well actually 4 other locations. The air vents themselves, the demister vents, and the top of the air vents here. You can basically see the line where it started, where that milling machine came in and had to cut out. So I have several very expensive tools. I have a milling process. I have an operator hand cutting. This is still an inexpensive way of doing it depending on the type of shape that you want your finished part to be. But that's a lot of processes. I would try to avoid that if I could. Also, this stuff feels like tire rubber. This is not something that I would like in a luxury vehicle. Let's talk about the crossguard beam for a minute. The crossguard beam is the structural support that supports all the rest of the instrument panel. Some vehicle designs actually require or rely on the strength of the crossguard beam, also for side impact. Now, I would prefer not to have to worry about penetrating through the body of the vehicle and then into the instrument panel side impact when I'm literally sitting right here. I don't have the support here in space, but I have the support here. But this crossguard beam is welded assembly. This is very common, this is very basic, this is fairly inexpensive. However, it's only inexpensive under certain conditions. Think about this. Every one of these individual pieces of steel is a different stamping tool required to make it. If this is done in a progressive die, it might actually be multiple hits for every single piece. If you add that up across the entire assembly, you'll realize you're going to come to a point, depending on how many different stampings you need to execute for support of your structure, this could become very expensive. All of these pieces now have to be put into a jig or into a fixture for all of the welding. Now I'm welding to a round tube. What happens if I was off by a little bit on this round curve for these weldings? Well, now this component's not going to be in the right spot. So I have very critical fixturing to do this entire weldment. What are some other ways that people do this? Well, let me show you. This is a cast magnesium crossguard beam. This is all done in one piece. In theory, this would be one tool where that could possibly be 100 tools. This can also save weight. Magnesium is very, very light. But can you do this wrong? Yes, you can. Think about it. Looking at this steel crossguard beam, all of these tabs are because I need an attachment in a certain position. If I can incorporate all of these positions into my cast magnesium, then I don't need anything additional. However, what tends to happen is someone very, very high up says, I saw this new technology and it's great. We want to use that cast technology for our crossguard beam. That's great. Then it starts to filter down to the people that actually have to work on it. They come up with something, but then they say, well, you know, we have this part or this feature that we need to reach out to. Well, let's just add a bracket on top of this. All right, all of these screw points are points where they added on another bracket across this crossguard beam. I think this beam had 27 brackets included on top of the magnesium. Well, looking at how many brackets are total on that part, if I am adding 27 on this, I have literally just added a whole lot of money when I did not need to. Then we look at a system like this. This is similar to what is in Tesla and similar to what is in Rivian. This has a hydroformed aluminum tube. All of this is an injection molding. All of the points where we need to reach out to are included in that injection mold. So this aluminum tube is my crossguard strength. That is one tool. And then the injection mold is one tool. So I, again, have just 2 tools. I can reach out. This can be light depending on how you design it. The problem, again, is, let's say I start with something like this and then decide, well, I need to reach out to here, here, here. Well, then I'm adding brackets on top of this. Now, I've done some should costs on some of these systems. That would be roughly between $40 and $50 depending on where it is manufactured. I've looked at systems like this, depending on the type of material that's used for the injection mold, and I've come up with a should cost really in the $40 range. However, I know that right now that because this is used so infrequently and because there was a company that had a patent on it and they were asking a premium, lots of these were actually going in the $70 to $80 range. Tesla, we saw on the Model S, try to get out of that patent by having a different type of structural forming. So we'll have to see where that goes in the future. I like this, but now here's a question. What if we let structure be structure? What if the crossguard beam does not have to support the strength of the overall crash readiness? What if this was all plastic? What if it was one tool and I could just injection mold it? Well, in truth, depending on what I had to support, you'd end up with some very thick plastic, especially once you got onto different issues with die draw and the amount of draft that you need in the part. Having some sort of a hybrid between, I would say, steel rather than the aluminum, a simple steel stamping overmolded with the plastic, I think would be best, but I don't like having to do dual duty. If we have some sort of structure built into the vehicle, I want the structure of the vehicle to be structure and allow this to just carry the instrument panel, which is what it should do. So these are both styles of air ducts that were used inside of the Skywell. This is just a simple blow molded air duct. Very inexpensive, fairly rigid. You can include these attachment points into the blow mold. But over time, people have gone into materials like this, trying to say, well, this is even lighter and it's a sheet form, thermoformed, welded together, very light, fairly flexible, makes it easy to install. Let's use this. Now this can be done well. Let me show you a sample. This is a large duct diffuser. Has all 4 locations across the front of the instrument panel. Here's where the air is coming in from the HVAC system. This is simple, this is lightweight, very, very inexpensive. How did they mess up? Well, someone decided, well, you know what? We're not really sealing on this end very well, or it's not really attaching. So we're gonna add in a zip tie. Well, how do we hold that zip tie in place? We're gonna weld a tab that locks the zip tie in place here and here. So now I've added material and I've also added more processing. We want this vent to secure a little bit better. So we're gonna take this injection molding and we're going to heat stake the material to the injection molding, and then we're going to be able to attach that to our instrument panel. Well, now I went from having the idea of a simple, lightweight material. Now I've added on this processing, added on this extra material, and then more processing. This has now killed the idea of having something simple and lightweight all in one shot. So in my opinion, they should have just stuck with using this rather than trying to go fancy, because they did not execute it well. Here's the faux wood grain. Now, this is not real wood. This is an in-mold film. However, it's a fairly good one. If you look across this surface, you'll see how it looks like it is open-grained wood. It's not a high-gloss plastic looking wood. This is the style that is most appealing in today's climate. I like the open grain look myself, makes it look more like wood. However, this is not wood. You can see right there. That is some over-edge wrapping from the in-mold film. I like this material. The good thing about having this being an in-mold film is basically this is a printed material. I can print off another sheet if I wanted this to look like diamond plate, put it in the mold using the exact same tool. If this was real wood, there's a thickness in that that is required for the real wood. You would not be able to switch out between real wood and another material on the same tool. So this one allows me to switch out this style on the same tool because this is just a printed film. So I do like that execution. Let's talk a little bit about light pipes. This is the chrome trim that runs across this instrument panel. On the bottom of this chrome trim, there is a light pipe. This is what's giving you that mood lighting inside of your vehicle. These are the actual light sources. Inside of there, there's just an LED light that is shining out that is running down a tube. Let's take a close look at those tubes. Right here, this tube pops into that diffuser. Now I've worked on these in the past and we had a little issue long time ago. We would have a perfectly clear tube, we would put in the light and all of the light would come out the other end. or you'd have one spot that was very, very bright at the end of your instrument panel. Then we would have more of a frosted material. Then it would take all of the light at the very front and it would not be even. This material, if you can see here, see these little hash marks? Those hash marks actually grab a certain amount of light as it's traveling along this tube and reflect it back at you. Now you'll notice those hash marks, they actually change over time, saying I need more light to come out here, this I want to be a little bit more even, and then they're all starting to get closer together, closer together, closer together. So I can tune how this light is being reflected into the vehicle based on changing these hash marks in the tube. Now, at first we did not do that. They are now, but that's from basically when I was in a research group over a decade ago. This is what I would say is the linear portion of the air vent. We talked when we had the review of the vehicle that basically it looks like one big air vent, one big line going from side to side of the vehicle. Now that's not true. This is all just decoration. This is an injection molded painted part that is heat staked into this main carrier. There is a chrome lip through here. Now you'll see if you look at the very end where that chrome lip is being attached to this component. So I have 1, 2, 3 components in this assembly. This is just raw injection molding material. This is painted. This is chromed. Attaching to that is the air vent. I'll tell you right now, I hate costing air vents. This is some of the biggest pain. All of the different assemblies that are in here, the amount of labor. Looking at this, these air vents, you notice how they're all loose? That's because the pins on this end actually engage in these holes on this part. So I have to attach and align these together as 2 separate components, not just trying to work within one. I don't like doing that. This is kind of a pain of an assembly. I've always hated costing air vents, trying to figure out, I have a diverter in here. All right, that's an injection molded part, but the edges are coated in rubber. So now I have a 2-shot rubber part. Where do I figure out where those costs are in this system? I hate air vents. So now this is the decorative trim that went around that entire assembly. This decorative trim is a PCABS material, and it is painted. This has that piano black paint that we like picking on right now. That is around this air vent and also the air vent on the other side. Very, very delicate to handle these components. Now you'll see these are where this part snaps in place. Trying to take it apart, I actually broke one of them. But assembling this to the vehicle, knowing that this is flexing around so much, having to put it in place and then pop, 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 snap it in place all around. I just don't like having to handle something that's that fragile, that flexible. We have a couple of different screens here. This is our center display screen. Now this is the one that basically looks like an iPad. We've had that discussion and other people have come up because we talk about these screens and I say how much they cost. I said, why does it cost that much when I can go and buy a pad off the shelf at Best Buy for $400, $500? Well, this is unique. More than likely, it's unique to this vehicle. Anytime I'm trying to manufacture anything that is unique to a specific vehicle, to a specific volume, the price is going to go up. So I've actually worked with some startups that wanted to, rather than have a dedicated screen designed for their vehicle, just have a mount that would allow them to mount any off-the-shelf screen. That can work. The problem is those off-the-shelf screens, how often do they update an iPad or a part like that? Every 2 years? Every 3 years? How long does that vehicle tend to be on the road? 10 years? So does that mean I have to try and find some old component if I need to replace the screen that will then fit into my vehicle? Honestly, it makes more sense to design them for the vehicle. Now, if you're an OEM that you have multiple vehicle lines, maybe you can use the same one across multiple vehicle lines, save you some money there. But it just doesn't make sense to just take an iPad and slap it onto the instrument panel. This is the display screen that's behind the steering wheel. I'm actually kind of criticizing this one. It seems to be very heavy the way it is built. This is different from most of the cluster display screens that I have seen on a lot of the other vehicles I've torn down. We still have to tear into this to really cost it and understand what caused it to be this way, because this is very, very heavy. So again, the teardown on the Skywell has just kind of been a fun time for Munro. Again, this is something that was purchased at an auto show several years ago. It's not even available in the US. I don't know if this vehicle is still being produced, or how it is still being produced. So it's just been fun for us to be able to tear into it and see where the differences are to how we would design something in the US, or how some of our customers currently design things. So if you are interested in some of the things that we've seen within the Skywell, please stay tuned to future Munro live videos. If you have not subscribed, please subscribe if you do want to see more of this content. Have a good day.